Union Pacific spent years designing a 6,000 horsepower locomotive to haul 3,600-ton trains over the brutal Wasatch grades during World War II. They were going to call it the Wasatch. Then, an anonymous worker in Schenectady grabbed a piece of chalk and scrawled 2 words across the smokebox. Big boy. That joke was never supposed to stick. So how did it become the name of America's greatest locomotive? Otto Jabelmann's engineering brief arrived as a single page, but it carried the weight of an entire railroad's future. Facing the Wasatch Bottleneck, Jabelmann demanded a locomotive that could do what no engine had done before: pull a 3,600-ton freight train up a 1.14% mountain grade without a helper. The challenge was not just one of brute strength, but of physics and precision. The brief set an uncompromising axle load, no more than 65,000 pounds per axle, to protect the fragile mountain track. To meet this, weight had to be spread across 12 driving wheels in an articulated 4884 arrangement, a configuration never before attempted on this scale. The boiler was specified to deliver at least 6,000 horsepower at 300 pounds per square inch, enough force to sustain the climb without stalling or slipping. Jabelmann's adhesion calculations, preserved in the original memorandum, called for a tractive effort of 135,000 pounds force, nearly double that of the most powerful Northern-class engines then in service. The firebox had to be massive, with over 150 square feet of grate area, and the entire machine would stretch 132 feet from coupler to coupler, longer than most city blocks. Every figure was driven by necessity: the steepness of the Wasatch, the surge in wartime traffic, the impossibility of adding more crews or locomotives when every available resource was already spoken for. Jabelmann's brief left nothing to chance. The boiler pressure, driver diameter, wheelbase, and even the articulation geometry were all dictated by the relentless logic of grade resistance and track curvature. ALCO engineers responded with line-by-line calculations, matching each requirement to a physical solution. The 4884 design was not just a leap in horsepower, it was the product of a technical blueprint where every dimension served a single purpose: to move America's freight faster, farther, and with fewer hands. Wartime urgency meant there could be no compromise. In the end, the numbers did not just add up to a machine, they added up to a legend, born from the intersection of geography, ambition, and the unforgiving demands of war. Union Pacific's main line between Ogden and Green River became a lifeline as the United States plunged into World War II. The War Production Board singled out the Wasatch Corridor as critical, funneling everything from aircraft parts to armored vehicles across the mountains to the coasts. Every day, the railroad's monthly ton-mile reports showed freight volumes climbing, first by a quarter, then by a third. Trains grew longer, heavier, and more urgent. Yet every ton that crossed the Wasatch grade came at a price. Helper locomotives had to be added, each one demanding its own crew, fuel, and precious hours. Yard logs documented the ripple effect. Delays stacked up, trains idled on sidings. War material waited while the railroad scrambled for enough engines and men. The cost wasn't just measured in dollars. Wartime logistics demanded efficiency on a scale never seen before. The War Production Board's records show that the Wasatch Line ranked among the top 5 bottlenecks in the national rail network. For Union Pacific, the stakes were clear: either solve the helper problem or risk falling behind on military deliveries. The big boy was not a luxury, it was a necessity forced by the relentless arithmetic of war. Crew hour costs had to drop, and the only way was to move more freight with fewer hands. War Production Board documents show that after Big Boy's arrival, the average train length on the Wasatch jumped from 70 to 95 cars. Helper assignments plummeted, freeing up 12 engine hours per train every day. The economic payoff was immediate. Without the drag of helper delays, freight flowed faster, and the railroad's operating costs fell sharply. Union Pacific's own ledgers recorded a 38% cut in crew hour cost per ton mile and a 24% drop in fuel use. The Wasatch segment's daily throughput soared from 5.5 to 7.6 million ton miles in just 6 months. These numbers weren't just internal milestones, they were the difference between meeting or missing the war's logistical deadlines. In the shadow of wartime urgency, the Big Boy became more than a technical marvel. It became an indispensable tool in the arsenal of democracy, its performance measured not in horsepower alone, but in the steady, unbroken flow of trains across the mountains. Union Pacific's paperwork called it the Wasatch class, a name chosen to honor the mountain barrier it was built to conquer. Engineering memos, shop tags, and internal correspondence all used the formal designation, Class W. Yet in late November 1941, as the first 4884 prototype waited for its final coat of paint inside ALCO's Schenectady plant, something unexpected happened. A worker, anonymous in the records but likely a foreman named Jack Miller, picked up a piece of chalk and wrote 2 simple words across the boiler's side: Big Boy. The act was part joke, part statement of awe, and entirely unsanctioned by the railroad's branding committee. A factory photographer, Alvin Smith, captured the moment. The resulting image, number 4000 with Big Boy scrawled in rough block letters, quickly made its way through ALCO's archives and into the pages of Railway Age. Within weeks, the nickname had spread far beyond the shop floor. Press clippings from January 1942 show the chalked name appearing in national newspapers, while internal Union Pacific memos began referring to the new locomotive as Big Boy, as if the company itself could not quite believe how fast the label had taken hold. The contradiction was impossible to ignore. Years of engineering deliberation, months of design reviews, and a naming process rooted in geographic pride were swept aside by a single off-the-cuff gesture. The machine that was supposed to be the Wasatch became Big Boy almost overnight. That chalk scrawl did more than name a locomotive. It gave the engine a myth, a sense of personality, and a legend that would follow it through every mile of wartime service. It is a reminder that even the most monumental feats of engineering can be shaped by the smallest, most human acts, a name scribbled in chalk, echoing louder than any official decree. 25 Big Boys took to the rails between 1941 and 1944, each assigned to the steepest, most demanding runs between Ogden and Cheyenne. Wartime urgency kept them in near constant motion, hauling mile-long trains of tanks, coal, and wheat. But as the 1950s unfolded, the railroad's priorities shifted. Diesel-electric engines, cheaper to maintain and easier to operate, began to sweep across the Union Pacific system. The Big Boys, once the pride of the fleet, found themselves outpaced by technology they had never been designed to match. Retirements began in 1959, and by 1962, the last revenue run had ended. 17 of the giants were cut up for scrap, their parts sold off by the ton. Only 8 escaped the torch, set aside for museums and city parks. A fraction were preserved, the rest erased from the rails. Engine crews, who had once boasted about the thrill of running 4,000 tons up a mountain grade, now watched as their favorite machines were sidelined by progress. Union newsletters from the era capture a mix of pride and regret. The Big Boy's size had once made it a hero, but in peacetime, it became an expensive relic. The rarity of these survivors gives weight to every bolt and bearing that remains. Each preserved engine stands as a silent witness to a vanished age, a reminder that even the mightiest machines can become vulnerable when the world changes around them. In April 2013, Union Pacific bought back Big Boy number 4014 for just $1. The locomotive, silent for decades at the Rail Giants Museum in Pomona, California, was set to make a 1,250-mile journey back to Cheyenne. Every mile required careful planning, Crews drained the tinder, checked every bearing, and negotiated with each railroad along the route. The move became a rolling event, drawing crowds who watched the giant return to its old territory. Inside the Cheyenne Steam Shop, the restoration team confronted decades of wear. The original firebox held nearly 800 stay bolts, but over 500 had to be replaced by hand. Restoration logs detail weeks spent on hydrostatic tests, pushing the boiler to 350 pounds per square inch, 50 pounds per square inch above its original rating to guarantee safety. Steel sheets were shaped to match 1941 blueprints from the American Locomotive Company, while new piping and digital monitoring systems were tucked beneath the old gauges. The team balanced historic detail with modern standards, blending tradition and technology. On May 1, 2019, number 4014 moved under its own steam for the first time in 57 years, its whistle echoing over the Wyoming plains. The Cheyenne Historic Mechanical Crew, veteran railroaders and new apprentices, stood by as the engine accelerated, proving Jabelmann's wartime calculations still held. The revival became a living answer to whether America's greatest locomotive could run again, its nickname now a symbol traveling city to city. A single chalk scrawl transformed a feat of engineering born from wartime urgency and mountainous necessity into legend. Today, Big Boy endures as proof that even the smallest human gestures can magnify power and ambition. The true machinery of history often turns on moments no one plans. What will ours be?